Hello, this is Mr. Weideman at Lafayette High School, and this is our function and trigonometry class. This is a homework assignment from section 6.1. It's part B, page 651. Here we go, part B, page 651, number 23 through 47, omit number 45. And I'm going to do several of these problems for us here on this session. These problems were significantly more challenging than in part 1, but I'm going to show you that typically using our strategies that we learn for part A is going to get us through. So let's take a look at this one here. Now, what am I going to do? Well, we're going to pick the icky side. That would be the left side. And I'm going to get everything in terms of sine and cosine. So if I have any reciprocal functions like secant or cosecant, I'm going to write those in terms of sine and cosine. If I have tangent or cotangent, I can use my ratio identities and also rewrite those in terms of sine and cosine. So that's what I'm going to do here in the tangent. I'm going to write it in terms of sine and cosine, and then I have this other term right here. I'll leave that alone. And the next thing I'm going to do is this has an addition operation, so that's exactly what we're going to do. We're going to add these together, which means that they're going to need a common denominator. Now this looks like we're working backwards, making things more complicated instead of less. But typically if there's an operation, a plus or a minus, at some point in time during the simplification we're actually going to have to do that. Alright, so I am not going to distribute the denominator. I'm just going to leave the denominator alone, but the numerator I am going to distribute these terms through, and then I'm just going to leave the denominator as cosine t times 1 plus sine t. Alright, and then I see a sine squared plus cosine squared, and I have a Pythagorean identity. Well, that's just 1. And this is one of the reasons I don't distribute the denominator, because I can see that 1 plus sine t cancels out. That happens a lot. And I end up with 1 over cosine t, which we know is the secant. Okay, let's go on to another problem here and see what we have. Problem number 35. Okay. I am going to obviously pick the left-hand side. It's the ickiest. And I'm gonna get rid of all of my reciprocal terms, like the secant and the cosecant. It's kind of a typical strategy in this unit that works almost all the time. And then I am going to do something a little bit different here. Is I'm going to end up, I call this clear the denominator. All right, once I got everything in terms of got sine and cosine, I'm going to multiply through the top by sine and then the bottom by sine. And when I do that, you're going to see why this works out pretty well. So when I multiply that, that's sine over cosine. I know that's tangent. And then sine divided by sine, that's going to give me 1. And then on the bottom, same sort of thing is going to happen. And this is actually going to come together pretty nice, pretty quickly. Right, by converting reciprocal functions in terms of sine and cosine, and then clearing the denominator. Oops. Is that it for that? Yeah. All right. So we can see then what happens is this guy becomes 1. This guy becomes 1. This guy is my tangent in the numerator, and this guy becomes tangent in the denominator. And then we verify that identity. Okay, let's take a look at number 39. And 39 has sort of a weird operator here, or weird argument. You know, they call it 2x. Okay, just instead of 2x, I'm just going to use, I don't know, little kitty cat face here or something. It doesn't matter. It's just a common input value. Now, what would be complicated is if the input value were different, like one had a 2x and one just had an x, and maybe one had a 3x as an input argument. Okay, then things are rough. You need an entirely different strategy. But just think of that 2x. It's just an input variable, and it can be treated as such. And then we can see I've got a sine squared plus a cosine squared is a 1. Tangent squared plus 1 is equal to secant squared. And that's one of our trigonometric identities. Okay, the idea here is don't let this argument or input argument of 2x throw you off. As long as it's tangent squared 2x plus sine squared 2x plus cosine squared 2x equals secant squared 2x, you're fine. It's just an input variable. I could put x or t or pretty much anything. Okay, I think 41 again has sort of a weird input argument, but they're the same. So I can replace it with just any kind of input variable argument that you want. And I'm going to take all my tangents and cotangents and cosecants there on the denominator. I'm going to write this entire expression in the terms of sine and cosine of my input argument. I'm going to use the same trick as I used on the other problem. I'm going to multiply the top and bottom by sine, and why do I do that? Because it clears the sine in the denominator in one of the terms in the numerator and also the denominator. Okay, and let's see where we go from here. Okay, that's all divided by 1. Okay, so I've got sine squared over cosine plus cosine squared. What am I going to do next here? Okay, what I'm probably going to do next here is give this a common denominator so I can actually add them together. All right, so that is going to give me sine squared plus cosine squared over cosine. And then we know from our Pythagorean identity that is just 1. And so 1 divided by cosine is secant. Again, don't let that input argument throw you. It can be anything. Let's see, I have an alternate method here. Let's see what I do here. I don't remember doing this. Usually these alternate methods usually come from a student. A lot of students say, hey, Mr. Gleideman, can you do this? And it ends up being pretty clever. I think here, okay, we actually perform the division. Okay, dividing by 1 over sine is the same thing as multiplying through by sine. And this actually comes together very quickly. I kind of get to the same place. And kind of ends up being the exact same thing, just eliminates a move. And I'm going to again get to that place where I'm actually going to get a common denominator and perform the addition, and then come at the same place and get the same answer. So whether I multiply by the numerator or denominator by sine, or understand that in this move right here, that when I divide by this term is the same thing as multiplying by this term. Okay, I get to the same place. A little bit less work. Alright, this is the last one I'm going to do for us today. And okay, this one is pretty icky. And obviously I'm going to pick the left-hand side, work with it. And the first thing I'm going to do is I can see the right-hand side is all in terms of sine and cosine. So my first move is take the left-hand side and put everything in terms of sine and cosine. Now, we've got to be careful. The input argument is different. A sine x and a sine y, a cosine x and a cosine y. All right, so what I'm going to do here is I'm going to clear the denominator on both the top and the bottom by multiplying through by cosine x times cosine y. So every term on the top gets multiplied by cosine x, cosine y. And then we're going to see every term on the bottom gets multiplied through by cosine x, cosine y. And this is why we call the method clear the denominator. And then when I multiply through, that denominator in the lower term gets eliminated. And then let's clean this up a little bit. Well, I didn't have to clean it up a little bit. Problem was done. Let's get back to that. Okay, yeah, after everything gets scratched out, we end up getting what's on the right-hand side. All right, so what was the strategy? Put everything in terms of sine and cosine and multiply through top and bottom to clear the denominators, or the terms on the top and the bottom, and then everything simplifies out real nice for us. Okay, I hope this helps, and stay up on Student View for further help and everything on this particular section, and there'll be some assignments due when we return. Thank you for your time.